Bismillahirrahmanirrahim. Our project is experimentation of blade design parameters for performance improvement of hydraulic cross-flow turbine. Our group members are Muhammad Umair, Muhammad Haris, Muhammad Saad and Muiz Mahmood. Our project is supervised by Dr. Shoaib Naseem and co-supervised by Dr. Shakil Afzal. First of all, I would like to introduce the cross-flow turbine. A cross-flow turbine is a device used to generate power from hydro, a renewable source of energy. Cross-flow turbine is used for low-head energy power production due to its simple and easy to maintain design and operating phenomena. A cross-flow turbine is a type of turbine that is suitable for low-head and high-flow applications. Our turbine model were built with 4 different blades impellers. We will test the turbine with 20 runner blades. Aims and objectives. Our main aim is to check the power generation capability, to check how efficiently our turbine is working, and to check which blade profile is much more efficient. Types of impellers. We will build the 4 types of impellers. First of all, part A, round profile. As you can see, the edges are round. And in the part B, sharp profile, the blades are sharp from the edge. Part C, truncated profile, and part D are over profile. CAD model. This is our assembled CAD model in which truncated profile is being attached into the shaft. Methodology. The experimental setup was performed using the VDAS Tech Equipment MFP101 centrifugal pump test workbench. Impeller blades were 3D printed and was modeled with Trio 7.0 software. The analysis was conducted using ANSYS CFX Pre and the Flow Solver. The geometry and mesh were generated using ANSYS ICEM CFD. A two-dimensional hybrid mesh was generated for the inlet, outlet, and rotating body. Various parameters were considered during the analysis such as impeller rotational speeds, number of iterations, turbulence models, inlet pressure, outlet pressure, and a mass flow rate. The solver control utilized the equation of continuity and employed the RMS residual type with convergence criteria. Furthermore, these are the boundary conditions that we use for the analysis. We will give the reference conditions. First of all, diameter of impeller, length of blade, width of blade, thickness, angle of attack, inlet, outlet, pressures, mass flow rate, number of iterations, and rotational speeds. After that, we generate mesh in ICM CFD analysis module. You can check that part A, which is inlet flow of 2D mesh, and part B is outlet flow of 2D mesh. Furthermore, in part C, you can see that the rotating body, it contains blades. On the other hand, overall assembly is seen in part D. Comparison of experimental and CFX results. We have analyzed truncated blade profile and sharp edge blade profile. First of all, we discuss truncated blade profile. As we can see, the number of boundary conditions are same. Number of blades, rotation, head, and internal mass flow rate. While if we can see the results, power in experimental is 20 watt, while in CFX results 25.9 watt. Similarly, in internal mass flow rate, inlet pressure, outlet pressure, efficiency, and torque are different. Difference in our results is due to losses and different errors in experimental setup. After analyzing both blade, we concluded from results that sharp edge profile is giving more power and much more efficient than truncated. Total pressure contour. This is our post results for total pressure contours. We apply a condition that water flow starts from inlet and ends at outlet and opening. You can check how streamlines flow start from inlet to rotating body. The rotating body, you can check how water is flowing towards the blade edge. So after that, blades rotates about the speed of 500 rpm. At the end, we simulate different results. Socio-economic benefits. Hydroelectricity is the clean energy production and renewable energy source. It is highly economic and popular, especially in developing countries. It is a domestic source of energy, allowing each state to produce its own energy. Economically, it is cheaper than Wabda. Thank you.
Assalamualaikum ladies and gentlemen, my name is Mohammad Haris. Thank you for your attention. Today I would like to present our final year project which involves efficiency of crossflow water turbine with an aim to generate maximum power by using these blades, that is circular profile, truncated profile, sharp profile, oval profile. The motivation behind our project is to optimize the use of renewable energy resources in smaller scales such as rural or off-grid areas and in turn to contribute towards a more sustainable future. Here is the centrifugal pump, which is the type of pump that using a rotating impeller that increases the pressure of flow rate of the fluid. The pump operates on a very simple principle. The energy of the motor is converted into kinetic energy and then by the impeller. And there is two types of centrifugal pump, that is single stage centrifugal pump and multi-stage centrifugal pump. The maximum mass flow rate of centrifugal pump is 2 kg per second, but due to friction losses, we get 1.45 kg per second. The maximum speed of our centrifugal pump is 2800 rpm and the maximum torque is 1.11 newton meter. And the maximum output through centrifugal pump power is 328 watt. The power flow through these pipes and when the attack of water enters with 90 degree of angle of attack of the blades, the water hits the edges of the blades, the impeller moves, and the dynamometer behind this is which can show us the RPM power and torque of the impeller. By testing these blades off, we conclude that the sharp edge profile of the blades is very efficient, which gives